Okay. So my number one question was, what did you think is one of the most useful contributions to the field of astrobiology at this current point in time?
Yeah, so that's a really good question. As you know, astrobiology is at the intersection of so many different fields. Obviously, in the name, you've got astronomy and biology, but really to understand the possibilities for life in the universe, you need to also understand planets, right? How planets form, evolve. So there's a lot of geology and geochemistry. And to try to search for life in the universe, we often need to look for chemical signatures of that kind of life. So there's a lot of chemistry, organic chemistry, atmospheric chemistry. That's part of my expertise as well. So there's a whole bunch of different contributing factors that I would say lead up to what the field of astrobiology is all about right now. And some of the leading discoveries that enable us to ask these profound questions about the universe come from various different fields. So I'll name a couple of them. It's not going to be entirely exhaustive of where the field is at right now. But first, the first thing that comes to mind for me is the exoplanet revolution. This idea that we can actually detect and characterize, meaning come to understand what different planets are like outside of our solar system. So our solar system has numerous planetary-sized bodies swirling around the sun. We've got 8 major planets, a whole bunch of minor planets, asteroids, comets, etc. But that's just the beginning. There are all these thousands of planets that we've discovered so far in the Milky Way galaxy that just doesn't even begin to scratch the surface of the possibilities out there. We know that there are hundreds of billions of stars in the galaxy, and statistically speaking, probably each and every star on average has a planetary system around it. So the idea that we live in the age in which we can detect and characterize those planets means that we can actually hunt for signs of life on all of these different worlds. Imagine if you could only look for life in 8 different places. It could just be that life doesn't exist in those places and you'll come up empty. But now that we know of thousands of strange new worlds out there, we have the power of statistics behind us, and we can try to assess our loneliness or not loneliness in the cosmos with all of these different exoplanets. So that's number one. That comes mainly from the field of astronomy. The other major discovery, I think, in science that contributes to astrobiology comes from geobiology. So this is right here on Earth, understanding the diversity and evolution of life on Earth, and understanding that we actually live on a microbial world, and that microbes are extremely powerful beings when they act all together, that they have radically transformed the nature of our own planet by injecting all of this oxygen into the atmosphere that we need to breathe. If it weren't for the microbes doing this billions of years ago, we wouldn't have the energy sources that we need to sustain life like us on this planet. And also, we've been discovering microbes literally everywhere on Earth. Anywhere that there's a possibility for life on Earth, almost anywhere that there's a possibility for life, we find life. And these microbes have been able to adapt to circumstances that we call extreme. And so thus we call these microbes extremophiles. They love living in those extreme environments. But it's important to just flip the camera around every once in a while and recognize that to them, we would appear extreme. We need these very specific conditions to live that we think of as comfortable. But to them, they are just as comfortable in their, extremely acidic hot spring or deep at the bottom of the ocean. And this opens up the possibilities for life in the universe, because just because another planet doesn't look like Earth or doesn't have the exact same characteristics as what we would consider habitable doesn't mean that there isn't life there, because that life could have adapted to that particular environment. And that's what we see all over Earth. So I think that those two just widen the possibility space for life out there. The idea that there are many possible homes for life in the universe due to the exoplanet revolution, and the idea that life could adapt to a wide range of different kinds of conditions from the geobiology, these extremophile revolutions, make astrobiology just such an exciting field.
Yeah, that's a really good point. I think about that a lot, and all the incredible habitable planets out there, and just not knowing what exactly are on those. And I'm just excited for the advancements in science too, and like even more planets that will be discovered just in the upcoming time. But yeah, that's super interesting.
Exactly. It's up to your generation, should you choose to accept the challenge, to bring us to that point where we can actually try to figure out if there's life on faraway worlds. We're just entering that age where technology has gotten us good enough to be able to try to answer these big questions.
Mm.
But I have no doubt that it will take a lot of hard work in the years and indeed decades to come to make sure that we have actually found that signal. Especially because when you think about extremophiles and then you kind of marry that with the idea of exoplanets, these planets are so far away. We're looking for microscopic life on a planet that is light years away. How can we possibly do that? It will take a lot of effort, a lot of innovation, a lot of creativity, and a lot of hard work. Again, probably taking many years and decades to actually make that definitive discovery. But it's really up to folks like us to take charge of this and to make this a mission for science to really revolutionize how we view our place in the universe.
Yeah. That's super interesting, especially with the Hubble telescope, and then what they're doing with the Kepler telescope. I think it was. It's all the stuff that it's discovering. Yeah, but that's. I'll let someone else ask a question now.
Yeah,
Um,
yeah. Well, just to go off on the telescopes,
yeah.
real quick, the Kepler telescope unfortunately has ended its mission. So it was one of humankind's greatest planet finding machines. But there are different kinds of telescopes for different purposes. So Kepler was great at finding planets. Hubble is good at trying to understand what those planets are made of. So what's in their atmospheres? Can we hunt for signs of life by detecting the types of gases that life would produce? But there's another telescope that you may have heard of recently called the James Webb Space Telescope, or JWST, that is even better than Hubble at doing that job of trying to identify gases in planets' atmospheres. And so that will be the main tool that we use going forward in the next 20 years or so. And we've got this brand new technology that launched like 2 years ago. So we're just getting there to the point where we can make these profound discoveries. So look out for news from the James Webb Space Telescope. And if you continue along your academic journeys, in astronomy for Rachel, you may use the James Webb Space Telescope one day. And for Jordan and Anders working on engineering, maybe you're going to build the thing that comes after JWST to get an even better glimpse at this, right? So yeah, again, it's up to us. Let's do it.
Thank you. That was super interesting. For I don't know who has question number 2.
So my question was, does space evolve? And if so, how does this, I guess, affect our specific solar system?
Yeah, so this is a really good question. Space itself is doing things, which is kind of strange to think about, right? In our normal day-to-day life, we just think of space as sort of like this empty vessel, which we can move around. You can throw a ball through space, but space itself doesn't do anything. But when you start thinking on astrophysical length scales, like the size of the universe, it turns out that to really understand what the universe is doing, you actually have to stretch your minds and allow space to do things too. So space can bend and warp. So for instance, that's our current conception of what gravity is, that gravity is basically the warping of space-time due to a very massive object. So like the sun warps space so that the Earth sort of orbits in this warped space around the sun. And space can also just expand itself. And the entire universe was discovered to be expanding. The first evidence of this came from a man named Edwin Hubble, who the Hubble Space Telescope is named after for this amazing discovery. And since then, astronomers through the decades have confirmed that, yes, the universe is actually expanding. Not only is it expanding, it's actually accelerating in its expansion. It's expanding faster and faster each and every day. So how does this expansion of the universe, because of space itself sort of like stretching, influence the solar system, was the second part of your question. And the answer to that is it doesn't really influence it at all, because the solar system is still pretty small compared to the length scales at which this expansion matters. So things that are bound together by gravity don't really feel this expansion too much. Although the space is expanding between Earth and Venus and Earth and Mars and Earth and the Sun, etc. Because of the force of gravity, the solar system sticks together. It's only on these extraordinarily long scales, like between galaxies, does the expansion of space-time really matter.
Thank you so much for answering that question.
For Jordan B.
Yeah, so my question kind of already got answered. So I was wondering, would you be okay, Dr. Wong, with me kind of changing my question around? I don't want to like put you on the spot.
Sure, go for it.
So my question was, do you think that there's life outside of Earth, which you did a great job of explaining that there is? So with that being said, do you think it's possible that that life on other like in other planets or in the solar system or wherever it is, that it could ever come to Earth, like and visit us? I know we always hear about like invasions, which I'm not trying to go like too sci-fi, but do you think that there's a possibility that that could happen?
Okay, great questions. So I'm actually going to answer your original question first before I get to the second one, because I don't think I was super clear when I was talking about alien life at the very beginning. What I was talking about at the beginning with extremophiles and exoplanets was the possibilities for life, that there's a wide range of habitats that life could evolve in and could exist in elsewhere. But we haven't discovered that yet, right? Like I said, it's up to our generation to try to make that profound discovery. So in terms of whether I think there's life out there, I actually don't know, right? As a scientist, I can't say that we know that because we don't have the data yet. So I think that there's a good chance that life exists elsewhere. And I think that it will take a lot of hard work to prove that it does scientifically. Okay, so with that out of the way, the idea that life could be out there, but we don't know, now the question is, if it does exist out there, could it come to visit Earth? Now, there are reasons to think yes and no. The reason to think that no is, well, space is really large. It's mostly empty space. That's why we call it space. And so far, humanity, despite all of our brilliant innovations and technology, we haven't even traveled to the nearest planet yet as humans, right? We've sent our robotic spacecraft, our rovers, we've sent orbiters and flyby missions to take pictures of and study other worlds, but humans have gone as far as the moon, and that's another world, but that's not a different planet yet. And that's relatively close by. And we'll see, maybe the technology that we'll get in the next coming years, and if the political will is there and everything like that, we may one day step foot on Mars. But again, that's still just like literally in our cosmic backyard. In order to cross the great divide between our solar system and another solar system, it may take enormous amounts of new technology and willpower and funding to do that, because the nearest solar system to us is about 4 light years away. That means if you were traveling at the speed of light, it would take 4 years to get there. But the speed of light is something that we can never achieve as humans. So it may take, who knows, hundreds, maybe even thousands of years for our spacecraft to just bridge that tiny gap between our solar system and the next closest one. So the enormity of space and the fact that we've explored as humans and visited just a tiny fraction of it kind of makes you think, maybe not. Maybe most planets out there don't even reach a level of technology that allows them to hop to their nearest moon, even, if it's just microbes, or even if it's just like dinosaurs, right? Dinosaurs didn't build spacecraft. So who knows, maybe the evolution of life is such that in most cases, the life just doesn't achieve the types of innovations that it needs to make those giant leaps. Now, that's the pessimistic point of view. The optimistic point of view, if you want to be visited by aliens, that is that once you achieve the ability to hop from solar system to solar system, it should be fairly easy to essentially hop between one solar system and then make your way to all the solar systems out there. And so people have come up with these thought experiments. One of the most famous ones is by a physicist, computer scientist called von Neumann. And if you look at something called von Neumann probes or von Neumann replicators, John von Neumann hypothesizes that if you just built a robot whose program was to land on another planet and then take in raw materials from that planet and build a copy of itself and launch itself into space, that kind of probe will eventually spread across the entire galaxy in give or take a few tens of millions of years. And that's just a blink of an eye on the cosmological or geological timescales. And so if anything like that ever existed, we probably should have been visited already. And then you get into the question of, okay, well, if that has happened, or if that is so easy to happen, then why don't we see evidence of alien life already here on Earth? And that brings up a famous paradox from a physicist named Enrico Fermi, who asked the question, the very innocent question, where is everybody? Where are all the aliens? And so that's called the Fermi paradox, and people have been struggling with that question ever since. So why don't we see evidence of technological civilizations out there? And I'm actually very curious to hear your thoughts. What do you think is the reason why we live in this universe full of possibility for alien life and the evolution of life? Why don't we see evidence of alien civilizations? Why don't we live in a universe that looks like the Star Wars universe or the Star Trek universe? What do you think?
So first, I just want to say I really like that perspective of we don't even have that technology. So how could other places, or not how, but other places might not either? That I never thought about that, but that makes so much sense to me. So for me, I don't know what I really believe. I know people have said, like, with the government coming out that aliens are like real or whatever. I don't know how much of that's conspiracy or whatnot. Sometimes I just think that if we have had those experiences with other forms coming to our world, that it has to be in a situation where maybe we just didn't know, like maybe they don't make themselves be known, because if they have the technology to be here, they probably could be hiding and we wouldn't know, right? Like they could conceal themselves. But it's kind of creepy to think about it, but it's interesting, and it'd be cool if they were here, I guess, as long as they were friendly, right?
Yeah, that's a great point. And they could be, in other words, if they've achieved the ability to traverse the huge amounts of space between different solar systems, they must have an understanding of technology and physics and science that is way beyond anything that we comprehend right now. And so that means that they may be visiting us in ways that we just don't understand and we cannot recognize. Or maybe they've invented ways of knowing about us that don't even require them to physically come here. Maybe they're just studying us from afar, right? And so they don't leave any trace at all because they weren't here. They just know about us from understanding how our planet appears to them through whatever incredible telescopes or observatories that they've built. Their understanding and their perception of the universe may be incredibly different from ours, just as our perception and understanding of the universe differs enormously from other life forms here on Earth. You think about, the different ways that we can perceive our environment from I don't know, just like a bacterial colony, right? The bacteria may be able to sense local changes in chemistry on like microscopic scales, and that's good enough for it because that's all it needs to survive. And so if you look at the gulf between us and a bacterium, well, we're both alive. You think about what's the next leap beyond us, the leap between us and whatever that interstellar civilization is, how far and differently do they perceive the cosmos in a way that enables them to know about us in a way that that we can't necessarily know about them in reverse, right? It's not necessarily like a two-way thing. It could just be a one-way street. So yeah, I really love your idea.
Thank you. I appreciate it. I like all of your ideas as well.
So for question 4, this is pretty relevant to what we were just talking about too, so it's perfect. I was wondering, I'm sure you've heard about the big boom in like UAP sightings and even like the hearing with Congress with David Grush and with all that type of stuff. So I was wondering is what your opinion on some of that is and whether any of it could be verifiable in sort of a way or how reliable any of it is.
Yeah. So this is a really great question, and really gets at the heart of what it means to be a practicing scientist. So first of all, I don't work for the government. So I'm a private citizen. The government, the Pentagon, the military, they don't tell me anything that they don't tell you. You know, we have the same information. In other words, so I don't have any top secret classified in intel at all. So what I see as an independent scientist and as an observer of what's going on right now is that we clearly don't fully understand all of the things that we see here on Earth. Okay, there are some unexplained phenomena that we are observing in our skies. Now, that is very different from saying that we have definitive proof that we've been visited by aliens, right? Because it's literally, we are saying we don't know. That's what UFO means, unidentified flying object, or UAP. What is the acronym now? Aerial phenomenon, right? It's like, it's literally an admission of not knowing something. That is so different from having accrued all of this evidence that one hopes you would have to claim that we have evidence of alien life. You see, there's a difference of, I don't know something versus I know it's alien life. And the amount of evidence that you need to make one claim versus the other is extraordinarily different. So I think what we need to be cautious of is equating our ignorance about what these phenomena are with any certainty whatsoever that they come from outer space. If they did come from outer space, and we can prove it scientifically, meaning through repeated observations supported by hypotheses that are verified, that show that there's evidence that they came from outer space, then the scientific method will eventually bear that out, that this kind of phenomenon simply cannot be explained by any other hypothesis other than the one that aliens have visited us. So far, I don't think the evidence is strong enough to say that. And so there are numerous scientific channels through which any claim of aliens visiting us, they're welcome to pursue those channels. And so the main way that scientific research is verified is through something called the peer review process. So basically, you write up a paper detailing all of the data that you found, the observations that you've made, and the conclusions that you draw from that. You submit it to a scientific journal, and then it gets reviewed by a panel of independent researchers. And if one of these UFO claims or UAP claims that this is truly a form of alien life survives that peer review process of a panel of experts, picking apart the data and all of the logic and reasoning, then maybe I will be more convinced that we have actually been visited by alien life. So far, what I think might be happening is that there are certain unexplained phenomena. And it could be alien life, and it could be a wide range of other explanations. And what we need to do is we need to systematically and scientifically study these phenomena, these anomalies, to understand better what they are. So I leave open the possibility that we've been visited by aliens, but I don't take it super seriously until the evidence points us in that direction and in that direction only.
Yeah, I completely agree with that. I have similar ideas about that. It'd be nice to look at it and feel completely convinced, that it is alien life visiting, because I think a lot of us, that's what we want, is to be able to have that claim to this century, is that we were able to definitively prove whether alien life is real and it's visited Earth. But I mean, yeah, it probably needs to be something a lot more concrete in order to adamantly say whether it's non-human. So that's pretty interesting. I wanted to get like a professional's opinion on that, other than all the biased stuff on the media and never knowing what I'm hearing is, I don't know what's going on. So yeah, that's interesting. Thank you.
Yeah.
then I believe I have the last question. I believe what. So you do podcasts on Star Trek, right? Just want to make sure.
Yeah, that's right.
Yeah. So how close would you say Star Trek is to like, I guess, reality or like in space and stuff? Do you know what I mean? Like how scientific is it?
Yeah, that's a great question. In some ways, Star Trek is extremely non-scientific in that it takes place in a fictional future where there are certain technologies that kind of bend science in the way that we know it, right? In order to just enable some kind of interesting storytelling out there in the future. For instance, they can travel faster than the speed of light. So far, there is no way for us to do that, although people have hypothesized ways to travel faster than the speed of light. They tend to all require some kind of exotic form of negative energy that nobody quite knows where that would come from in reality, right? So it's always kind of like at the edge of what we understand and just doesn't really comport with what is probably going to happen in our future. And that said, Star Trek does hire professional science consultants. So notably, they have astrophysicist Dr. Erin McDonald. She has a PhD in gravitational waves from the University of Glasgow. She advises everything in Star Trek on matters of astronomy, planetary science, astrophysics. They also have Professor Mohammed Noor from Duke University, who is a biologist and a geneticist by training, and he advises on all sorts of biological things in Star Trek. So they try their very best to root certain elements of each story in real life science so that people aren't just spouting gobbledygook that makes no sense whatsoever. So there is some baseline of truth to the ideas in Star Trek, but the story always comes first, right? If the story requires the physics to be broken, physics is going to be broken because it needs to be a compelling story. Where science can be inserted into the story to amplify the reality of that story, that's what they try to do with their science consultants. And I think they do it in the recent shows to a really good degree. And so the podcast that I run, Strange New Worlds, a science and Star Trek podcast, tries to examine what is real and maybe what is not so real about the science in Star Trek as a way for me as a NASA-funded scientist to give back to the community, right? So I'm funded by NASA, which means it's the American taxpayer who is really paying me because NASA is a federal agency. And so really, I just feel this personal obligation to give back to everybody, to say, look, this is what we've discovered in outer space, and here are all the wonderful things that we found. And the way that I know how to do that best is by tying that to a science fiction show that I love, and that's Star Trek. So I try to basically introduce cutting edge scientific concepts and discoveries through what we see in Star Trek. So we might say, oh, in Star Trek, we see this weird black hole-like gravitational anomaly. And then I'll go and interview Dr. Erin McDonald and say, how did you develop this concept? And what exactly is real about gravitational waves here? And what is maybe stretching the scientific facts a little bit into the realm of imagination? And through that, my podcast listeners will hopefully get a sense of like, oh, gravitational waves are like real, and B, really cool, and C, actually don't work the way that they worked on Star Trek, and that's okay. So that's basically what my podcast is about.
Sweet, thanks. And then I believe that's all of the questions we have. But thanks for coming out and or having an interview with us, I guess, today.
Yeah, no problem. I actually have a question for all of you, if that's okay.
Yeah.
Can I ask you, what is like the coolest thing that you've learned in your astronomy class with Professor Jackson so far? Like, what was the most mind-blowing like lecture or activity or just experience that you've had in this class so far?
Probably, I don't know. For me personally, I think it was like cool when they have it was picture of Earth from a telescope from when it turned around or whatever. I forgot what the name of the telescope, but it was like you could barely even see it, and like compared to everything else, it was like nothing.
Yeah,
Speck
so
sand.
humbling.
So mine was probably today. Today we learned about exoplanets, and apparently there was this one exoplanet that was theorized to have this core, because this core that harnessed sun's energy and it powered the whole planet. But this is like very, I guess, I don't know, stretch. Like we just learned it from our teacher today, and I forgot what it was called. Yeah, it was Dyson theory.
Dyson theory.
It was Dyson theory, and it was just really interesting. And it kind of went along with one of our questions about is there intellectual life or life on planets, and I thought that was kind of cool that scientists are theorizing that.
Yeah, the Dyson sphere, I think, is what you're talking about,
Dyson
where
sphere, yeah.
a civilization could build a shell around the star to harness all of that star's energy. And then you would think, okay, well, then that star is dark. How would you ever know that it was there? But that shell would eventually heat up to the extent that it would sort of like glow in the infrared, and then you could use your telescopes in the infrared to find it. And I think it would be, yeah, amazing if we ever found one. So far, all of our surveys have turned up empty, but they could be out there.
Yeah.
Yeah.
For me, I would also agree with Andres, and one of them, I believe it was a pale blue dot. He did, and Professor Jackson, he also did a part of the speech that Carl Sagan did from the book, and I thought that was really cool because I'm a huge fan of Carl Sagan. So hearing his words just like spoken out live in class, I think it was like one of the reasons that I got into science in the first place. So it was super inspiring. And then also with Jordan today, we did some studying on exoplanet transits, and wasn't aware before of how exactly some of that was done. And where to like how you find and discover like new planets and how when it makes its orbit around. And I thought that was super interesting to just basically track it on how the light reflection like comes back to Earth, and how when there's little or no light, it's because it's directly in front of the sun. And then that's how you can track, oh, it looks like there's a planet orbiting around. And I thought that was super interesting. And I kind of want to do more research about that. But that was for me personally.
Oh my goodness. Yeah, it is actually incredible how much we learn about planets by not even seeing them. We're just seeing their shadows on their stars. And to me, that's just, it honestly is kind of like, we're just chasing shadows. And yet we still know so much about the universe. So imagine the day that we actually get to study these planets by looking at the light that is coming from them, that is being reflected off of them, or that they are giving off intrinsically. Once we have a telescope that can do that, we will learn so much more. But we already know so much just by looking at their shadows, and that is romantic and inspiring and just so great. So yeah, absolutely.
So mine is probably cheesy, and you guys probably won't think it's very cool, but I actually found it really fascinating when we were talking about the sun and how the sun, like the orbit of the Earth and the sun, and how close the sun is to the Earth depends on like our seasons for our world, like how in other countries it will be like winter right now, but it's summer for us, that kind of a thing. What I thought was really interesting is that I never applied that like idea that the seasons are because of how far or close we are from the sun. And I lived in Montana for about 10 years. And if you ever lived in Montana, you'll know that sometimes by 6 o'clock at night, you're in darkness. You have no sunlight. And so it was just interesting to hear about like places where they have no sunlight for like maybe even a couple of months out of the year. So yeah, I don't know. I just thought it was cool.
Yeah, right. That our seasons are all because of the tilt that our planet has. That, there's a bit of the planet that is tilted more close to the sun, and that's where it's summer. And the part of the planet that's tilted away from the sun, it's winter, but it changes, right? Every time the planet goes around the sun. Imagine living on a planet that was tilted even more, that was so lopsided, like our planet Uranus in our solar system. Basically, one pole is facing the sun for half of the year, and the other half of the year, the other pole is facing. So you basically have permanent like sunlight if you were living in one of the hemispheres for half the year, and then the other half of the year, it's like permanent darkness. Like that would be wild. And you then wonder, like, if you were a life form living on that kind of world, how would you deal with that? How would you cope? What would you do if you needed sunlight for warmth or for, energy? And it just, really sparks the imagination. There are all these different planetary possibilities out there, and it could just be the tilt of the planet that makes a huge difference. And maybe did we get lucky that we have a slight moderate tilt and not something more extreme, or would life have been even better if we had a different tilt? Who knows, right? So yeah, this is again why planetary science and astrobiology are such interesting fields to study, because it's almost like a little bit of science fiction where you get to ask what if questions, right? What if this was actually the case? And then you actually go out there and you use your telescope or your spacecraft and you observe, and you're like, oh my God, that really is the case, and make these profound discoveries. So yeah, I'm having a lot of fun in my job. I have a lot of fun always, talking to people like you who are so interested in this subject. And I hope that you follow your passions wherever they lead.
Well,
Thank you.
It's the same time. But thank you so much for agreeing to interview with us today. It was great.
Sure, my pleasure.
Yeah, thank you so much. It was super interesting, and I find this stuff, I get super excited just like talking about it. So like hearing it all out, and it's just kind of re-inspires you all over again. And I'm like 10 times more excited, which I didn't think was possible. So thank you so much for this. And I would honestly love the opportunity to even get to interview you again in the future, for if I ever have that type of project again. But yeah, this was super fascinating. And you're really well spoken, and you explained it in a way that I was like, I can understand that and I can see what you're saying, which is definitely appreciated.
Oh, thank you so much. Yeah, I'd be happy to, stay in touch and see where you go and be interviewed again for whatever. So yeah, let's do it.
Thank you. I don't know if anyone else has anything else to say, or are we all
I have
good?
one last question.
Go for
So
it.
you like Star Trek? Do you like the newer Star Trek or the older Star Trek?
I love them both, honestly, and for different reasons too. The older Star Trek can be really campy and difficult to watch sometimes for various reasons, but they're inspiring, and you always have to you view Star Trek like any piece of art, where you have to kind of contextualize it in the time that it was created and understand that it was very pioneering for its time in so many different ways, whether that is special effects or the writing or the diversity of the cast or whatever it is, the kinds of issues that it talks about. And even though, a lot of those things, we've moved on from certain, ways of telling stories, or the production value has increased so much, just by knowing that Star Trek, was, oh yeah, that was created in the 60s and it was actually quite pioneering and good for its time, is makes it, kind of like a period piece almost. And also, one of the great things about Star Trek is that it not only reflects the kind of like social time in which it was made, but it also reflects the scientific time that it was made too. So you can look at the old Star Trek episodes and you'll hear them call things different names. Like they won't say black hole, they'll say like dark star or something like that, because in science we hadn't collectively decided to call things black holes yet. Or you can actually make a plot, and Professor Mohammed Noor, that geneticist who advises Star Trek, has actually made a plot of the usage of the term genetics in Star Trek, and you can see it actually increasing with time as the idea of DNA and genes and genetic mutations got more and more accepted in like just daily lexicon, right? The more normal people will know about DNA and genes, the more it can appear frequently in a TV show like Star Trek. And he shows that, yeah, actually, the people on Star Trek talk about genes a lot more in the later series than they do in the very early ones, before there was all this like genetic sequencing that we do nowadays for granted. So it's fascinating for both its artistic value, its storytelling value, but also just like being a reflection of the science that we knew in the moment that it was being written. And so that's super cool to think about as well.
Your turn, Anders.
What?
Just say thank you.
Also, sorry, one last question for me, I guess.
Mm-hmm.
What do you like more, Star Wars or Star Trek? I guess.
I love them both. Okay, I'm a fan of both fandoms and universes. I like Star Trek more, just because it's, you know, it was something that I grew up with as a kid. I grew up with both, honestly, but I remember distinctly watching Star Trek when I was like 4 years old, right? It was just like one of my first memories is watching Star Trek. And so I followed it. I'm like more complete and up to date with my Star Trek than I am with my Star Wars. I haven't watched all of the latest seasons of Star Wars. I think I haven't seen Andor. I haven't seen oh gosh, Ashoka, right? You know, all the most recent things. I'm behind. I'm just too busy with science right now, but I have kept up with Star Trek. And so yeah, it's one of those things where I appreciate them for different reasons, right? Star Wars, I think of more as like high fantasy set in space. You know, it's like it's science fantasy, and Star Trek is a little bit more science fiction in that it at least makes that attempt to meld itself with what we know in science. And Star Wars is just like, you know what? We just won't even touch it. We won't even try to explain it. And I think that's good, right? Because if Star Wars tried to explain how a lightsaber, I mean, like, how can you possibly have a lightsaber? It just stops, you know, like when you have a laser pointer, it goes on until it hits the wall, right? And so it's just like, I'm glad that they don't even try. And that makes me happy as a viewer because I don't worry about that and I just enjoy it for what it is. And I love it. It's great. Star Wars is so entertaining and it's a wonderful time. I love imagining myself in that universe, and Star Trek too. So yeah, they're different, they're great, and I love them both. I just love Star Trek a little bit more.
Sweet, thanks for answering that question.
Yeah.
Once again, thanks for taking your time out of your day, and I'm probably a pretty busy person, but yeah, thanks for having us interview, getting the opportunity.
Of course. Yeah, this was really fun.
Yeah, thank you so much. And once again, thank you for being here.
Yeah, no problem. All right. Take care, everyone.
Bye.
Bye.